Okay. The first concept in effective agile leadership I want to stress is quality. And there are high stakes for letting defects escape out to your customer. There's orders of magnitude difference of cost between finding and fixing a defect when a developer is working on the code for a feature versus it leaking out to the team versus it leaking out beyond the software team to product management, and then finally being deployed to a customer. And there's plenty of research on this, and so we don't want to let defects happen. We want to prevent almost all of them, and there's practices for doing that. And because even fixing defects is hazardous, 9% of defect fixes introduce a new defect. So the first priority, and of course, I think a lot of the engineering practices originally defined in extreme programming were aimed at increasing quality. And that's been a theme of research and even learning from lean manufacturing. Now, um, Edwards Deming passed away in 1993, but he was a leader in the quality revolution after World War II, and he published hundreds of papers and articles and books. And one of his ideas is the Deming cycle or Deming chain reaction, and that's used in quality control. And then, of course, that same idea has made its way into software. But the notion is you improve quality, and lots of good things happen. Less rework, fewer mistakes, fewer delays and snags. And then, because you're spending less time on rework and bad things that are happening, well, your overall productivity improves. Well, now the productivity improves and things go better with the software project. You capture the market with either a better quality or a lower price, and the business does better. You stay in business. Well, then the business prospers and grows and provides more jobs and more jobs. And then you start the cycle over again. You ask, oh, how can we improve quality a little bit more? And you do the cycle again. You do the chain reaction. So um, that has to be at the forefront of your mind if you're going to have if you're going to effectively use the concept of agile in your software team. Now, there are three methods for increasing quality that over and above um, just have a really good track record with research. Capers Jones is probably the best and most complete publisher of research in the software industry. I had the pleasure of having him as a guest on my podcast, the Azure DevOps podcast, about a year ago, and I've read a number of his books. And so, if you haven't sampled his research or his books or his summaries, I highly encourage you to do that. But for quality, to get up to 98% what he calls defect removal efficiency, that's finding and fixing bugs before they go to your customer. His research suggests that a combination of um, three practices be combined to achieve that end, and that's static analysis and testing and formal inspections. Now, a deep dive into each of those is outside the scope of this particular webinar, but those we're going to touch on a few of those concepts. Now, um, the foundation of your successful implementation of Agile is rooted in those engineering practices that prioritize quality from the outset. The Agile transformation is reducing batch size, but everything that the Agile community has talked about over the last 20 years has been discussions and experiments and hypotheses on how a team might best succeed in furthering the reduction of batch size. It's not that, like, for instance, extreme programming had iteration planning, and then of course Scrum adopted that and called it sprint planning. And then there's retrospectives, maybe there's planning poker, and then there's a sprint review, and some teams have a sprint commitment. And I mean, there's so many ceremonies, but all of those are hypotheses about how might we continue to be successful in further reducing the batch size. If you don't make any changes and you just willy-nilly reduce the batch size, well, then your quality is going to suffer. You're going to start shipping more defects from what you were shipping. Everything's going to be chaos. And so, um, and so the goal is to reduce batch size, and that's a measure of success. But then the question is, okay, how? How are we going to equip our teams to effectively reduce batch size to all the way down to making a single change and get that change quickly sent over to the customer and know that we haven't accidentally destabilized the software in any way. Okay. And so all the conversations have been about what practices should we adopt as a team? What skills does the team need? What kind of measurements do we need to have in place so that we can further decrease the batch size and then have a shorter cycle time and move faster without bad things happening? All right. So there's three things that I want to touch on here, and I want to kind of dive into testing a little bit more. But key among these practices is testing, and it has to be automated. Manual testing is just too slow. Manual testing ultimately in research is deemed to be too expensive and time consuming, and it leads to the widespread adoption of automated testing as a result, because it has to be that way. And then the practice of test-driven development, where developers write the automated tests simultaneously with the feature code, where you define a test and then you write the code to make the test happen, and you make asserts and then you factor the code. That is at the core of maintaining quality. And I'll demonstrate later that every type of effective test is essentially test driven. It's essentially test first. There's some debates on test driven development as it relates to unit tests, but when you look at it as a strategy, it'll make sense. And I'll cover that in a little bit. I want to just describe the static analysis that's effective briefly before I leave it, but it's another critical practice, and it identifies code issues without actually running the code. Your modern development environments and tools, they do have integrated static analysis built in, catching errors early in the development process. They just have to be turned on. And then there's other commercial tools as well that are effective. These tools, they not only improve code quality, but also enhance security by identifying potential vulnerabilities. And so SonarQube is a good one. Independ is a good one. ReSharper has a good static analysis built in. And of course, the third, formal inspections, which we're not really going to talk about deeply here. It's a term that may seem out of place in the Agile landscape, the word formal, but research has shown that formal inspections are highly effective in detecting defects before they escape the development environment. And these inspections, which they are formal because of the inclusion of checklists. They're checklist driven. They're integrated into, or the development one is best integrated into the pull request approval process. And that ensures a cost-effective and low friction approach to maintaining quality, but achieving the formality that gains the quality that the research suggests is behind this.